All right, so here we have a little bit different type of problem because we're given two reactants. We're given how much sodium we have and how much iron oxide we have. So what we need to do is figure out, given this much sodium and this much iron oxide, bar's not drawn a scale here, given these two reactants, how much, in this case iron, solid iron, can we make? How high does this go for Fe? We don't really care about the sodium oxide. The question just says how much iron can you make. So that's what we're going to be focusing on. So just like if I asked you to build bikes, you'd worry about the frames and the wheels separately and then compare and pick the lower number. We're going to do the same thing here. 100 grams of Na is one of the reactants that we're concerned, and we want to figure out if we use up all of that, if this hits zero, how high does this go? So we ignore the other reactant right now. We're just focusing on sodium. Ignore iron oxide. Assume we have enough of that. So use your balanced equation to figure out the numbers that go here. Now, sodium weighs 23.0 grams, but there's 6 of them, so 6 times that would go in the box. So we're just going to write this 138.0 grams there. And the iron, Fe, iron weighs 55.8 grams, and there's 2 of them, so we double it. So it's 111.6 grams. Do out the math, and you get 80.7 grams of Fe. So now I know that the bar for iron, the amount of iron I can make, would go up to 80.7 if I use up all of my sodium, assuming I have plenty of iron oxide. Now let's look at the iron oxide. We've got 100 grams of that too, Fe2O3. Now we're going to worry only about the iron oxide, forget sodium. If I have 100 grams of iron oxide, how high does this go? So I put grams of Fe2O3. I still put grams of Fe because I'm still concerned about iron oxide. It would be like, how many bikes? How many bikes? We're not making something different. We're just going to put the same thing on top. And then grams of iron oxide, we look over here. We get all excited because there's only 1 mole. There's a coefficient of imaginary 1 in front. We add up 2 irons, 3 oxygens, and it comes out to 159.6 grams. So if we do the math here, we realize that this tells us we can make about 69.9 grams of iron. So here's my dilemma. Can I make 80.7 or 69.9? You cannot make this. Put a big X through that. You can't make this because as soon as you make 69.9 grams, all of your iron oxide is gone. This hits 0 when this hits 69.9 grams. If you have no more iron oxide, don't care how much sodium you got, if you don't have any more iron oxide, this doesn't go up any higher. It stops at 69.9. It can't get to 80.7. So you're done. This is what we call your theoretical yield. You put that there on that line if you want. We know we run out of Fe2O3. That hits 0 when we make this. And we still have some sodium left over. We have enough sodium to make 80.7, but we can't do it because we only have enough of this to make that. So we stop just about 70. And then it says, imagine the reaction produces 52.6. So they did this, and they made this. They actually made that. The math says we should, in theory, make 69.9. So put this here on the bottom, grams of iron. And they actually made 52.6. So they didn't hit their target. We want to figure out how close they came. So we do this divided by that, and we realize that they made about 3/4 of what they expected to make. They made about 75.3%. So that, remember, this is a positive way to look at it. We could look at the flip side. They screwed up about 25% of the way. This was their error. We're not asking about error right now. What we're asking is what's the percent yield. So here's your target. How high or how close did you get to your target? That's how you calculate percent yield. Don't mix yield and error up.